Okay, this is chapter 8, number 7. I know there's one already on your Mr. Greenberg's website, but I spent a really long time on this. So, and I'm super passionate about this problem because it took me way too long to complete it. So, number 7. All right. Two objects are connected by a light string passing over a light frictionless pulley, as shown in figure 8.7. The object of mass is 5 kilograms is released from rest. Using the isolated system model, determine the speed of the 3 kilogram object just as the 5 kilogram object hits the ground. Find the maximum height to which the 3 kilogram object rises. Now, I don't know what the isolated system model is, but I solved it. The way I solved it may have been the isolated. I don't know. But all right. So what I did is I wrote out the givens right here, and I drew the position, the figure 7.8, and the final position of the massive blocks. I mean the position of the massive blocks when M1 contacts the ground. I labeled the ground as h equals 0. And we're solving for the velocity at which M1 hits the ground. So, to do that, you set the initial energy equal to the final energy, and you write all of this out. You write all the components out. So, in the initial energy velocity, you realize that, and I label each one as 4 meters and each two as 0 meters. Help me out. So going back to the left side, I just wrote out everything to the point where I did. So at the initial velocity for both blocks of mass is 0. So the kinetic energy is 0 for both blocks of mass. And the height at M2 the initial height for M2 is 0, so that cancels out. So we're left with M1 GH1 on the left side. On the right side, I pretty much just wrote all the components at the final, and pretty much at the final M1G, the height is 0 meters. CH2 equals 0 meters. So at the moment M1 hits the ground, height is 0, and we're solving for the initial velocity. And to solve for so we're solving for the velocity at which M1 hits the ground, and to do that, I labeled that as F, the final velocity for M1. Well, and M2, I guess. I just labeled the contact at which M1 has the ground as F, final velocity. All right, and so I just cleared out the terms that equal 0, and that's what it looks like. And then I isolated for the velocity. This is what I did. And eventually you'll get the answer of 4.427 or 4.43 in the back of your book. Just as a side note, if you were to plug in the values, you could cancel out some of the values. You see, 2 times 4 is 8 in the numerator, and 8 is the denominator. You could cancel those out, and you can just plug 2 times 9.8 into your calculator, and you should get the same answer, 4.43. So that's A. So part B, you're asked to solve for the maximum height at which M2 reaches. Now, what you guys should realize is that M1 and M2, the velocity is related. As M1 hits the ground, the velocity is the same as for M2, which is 4.43 meters per second, at which M1 hits the ground. So what does that mean? That means that M2 still has a way to go. It means it will continue to go upwards even though M1 has contacted the ground. So what we're left to find is the maximum height at which M2 flies up. And so what I did was that at the max, the velocity of the M2 would be 0, and I labeled the V0 as the final velocity that we saw for an A, which is 4.43 meters per second. Why are we using that instead of the specific value? Because I was too lazy. and so now we just solve for the height. And to do that, we set the initial energy equal to the final energy of block M2. Excuse me, I'm just gonna correct my fingers. Yep. Okay, so what I did was I just put in the values where I labeled the initial height at 4 meters, meaning the moment M1 hits the ground. So I'm pretty much that's where I label my initial height. And we're searching for the final height. Put in all the values. The final velocity should be a 0. So this term right here. Let me wait for the camera to focus. So the term right here approaches 0. And after that, the masses can cancel out. You isolate height, and you get this value, g initial height plus half v0 squared, which is all over the g. And when you plug in the values, you should get 5 meters. Yeah. Here's all the work, by the way, in case you want to see it again without, let me just get the focus. There you go. And the diagram too. Yep. It's kind of hard to get everything in